The solver tool in Excel is a type of what-if analysis tool, except that it allows you to find the optimal value or the objective for a certain cell. And in order to do that, you can set constraints on what values would be used to find that optimal value. In the Excel software, the solver might not be included, so I've got the instructions here to load that add-in under the File Options path. In this example, we'll look at a mortgage loan and specifically the monthly payment. I have my inputs here for the cost of the home, down payment, the interest rate, or the APR, annual percentage rate, the number of years you would pay, the monthly payment amount, the cost of the home, and total interest at the end of the loan. So in these cells, I have the formulas to calculate these numbers. And this is important because in order for the solver to go in and find these values, you have to have the formulas that point to those different cell references so that it can find the optimal values through the algorithm. I've included the original data here because when we run the solver, you'll be able to see the changes in the top of the data, and that will allow you to see the difference. We will also look at running a summary report, and that will also give you the same data. What we want to do in this case is we want to set up a scenario or a solver situation so that our monthly payment will be $1,000. That's what we can afford for our monthly payment, so we want it to be $1,000. The houses that we like tend to be within the $150,000 to $250,000 price range. And we only have up to $15,000 for the down payment, so we don't want to go above that. The market interest rates right now, let's say, are currently between 3.5% and 6%. And the loan we want for somewhere between 15 and 30 years. Normally they're either 15 years or 30, but we'll look at the span of those. So those will be our constraints. The house cost must be between $15,000 to $250,000. Down payment has to be less than or equal to $15,000. Interest rate has to be between 3.5% and 6%. And the number of years must be between 15 and 30. Once you've loaded the solver, you should see it under the Data tab. It's over here to the right. What I'm going to do is move this kind of in the middle so I can see my constraints and the data. I already have a couple of constraints entered for the number of years for the loan. It needs to be greater than or equal to 15 or less than or equal to 30. So it must be between 15 and 30 years. So for the constraints, you have to set, if you have a range of numbers, you have to set the bottom limit of the range and the top limit of the range. All right, to start off, we want to set our objective. And in this case, our objective is to set the monthly payment to $1,000. Okay, our monthly payment is here, and we're going to set it to a value of $1,000. In order to get it to that point, we are going to change certain cells. We're going to look for constraints in the cost of the home, the down payment, the percentage of interest, and the number of years to pay. And all of these are referenced either directly or indirectly through the monthly payment formula. Let's go in and add another constraint here. So we'll add the one for the cost of the house. It needs to be between $150,000 and $200,000. Cost of the house is here. And it should be less than or equal to $250,000. Add that. And it needs to be greater than or equal to that bottom constraint, $150,000. We'll do the same thing for the down payment. It needs to be less than or equal to $15,000. That's our limit. We don't have any more to pay than that $15,000. And the last one is the interest rate. The top of the range is 6%, so it needs to be less than or equal to 6%. And the bottom of that range is the 3.5%. So it needs to be greater than or equal to the 3.5%. Once we've entered those, you can see those listed here, and you can double check to see what your top and bottom ranges are. For the $15,000 for the down payment, we only had a top limit for that amount. Once you've completed this, you can go ahead and run the solver. Notice I've got my data here and then the original numbers. We'll go to solve, and I'm not going to worry about the solving method. I'm going with the default here. Once we solve it, you can see the data has changed here, and you can see in comparison to the original data, there are some changes in the numbers. We reached the $1,000 at a 3.5 interest rate, which is a really low interest rate. So that will save you a lot in interest. And the original cost of the home we can afford at $1,000 and 3.5%. In 30 years, we can afford a house that's $232,000. The original scenario, you can see you had a little bit more for the cost of the home, more for the percentage of interest. So you can see that that's really affected the amount of interest that you would pay at the end of the loan. What we can do here is go to the answer report. We're going to keep the solution. If we did not want to keep these numbers, we can just click to restore the original numbers. Once you do that, it will give you an answer report tab at the bottom. Gives you the report information at the top. It says it found a solution. If it cannot find a solution, it will not give you this new tab. When you scroll down, you'll see the objective cell, which is the monthly payment. We wanted that to be $1,000, and it was able to find a solution to reach that goal. The variable cells here are the original values. These are the final values, so you can see what has changed. And the constraints, you see that we have each of those constraints here. The binding versus not binding is a little bit different if you have ranges of numbers or a number that you want to meet. So for example, we wanted our monthly payment to be $1,000. It's binding because it met that criteria. For a number of years to pay, it had to be between 15 and 30 years. It's binding because it's at the top of the range, which is 30 years. You can see here. Our price of the house is not binding because it did not reach either the lower or the upper limit. The number is in between those. If it had been $250,000 here or $150,000, it would have been binding. So it didn't meet either of those upper or lower ranges, so it's not binding. And for the interest rate, we met the criteria here for the lower of the range because it's 3.5%, and that's what it found to be the optimal interest rate. So that value is binding. The down payment, which had to be less than $15,000, is not binding because we met that criteria by using a lower number.